In this problem, we're told that the price-demand equation for the production of television sets is given by the formula P equals a function of X, where X is the number of sets that can be sold at a price of P dollars. We're asked to calculate the marginal revenue at a particular value and interpret its results. We know that the marginal revenue is the derivative of the revenue function. So I'm going to need to build the revenue function first of all, so that I can then calculate the derivative, which is the marginal revenue. Once I have the marginal revenue function, I can evaluate at 3,000 and then interpret the results. So to begin with, the revenue function is the price times the quantity sold. That's how we determine revenue. How many we're selling times the price we're getting for them. And in this problem, our quantity is the number of television sets, and that's given by X. So the quantity is simply X. The price then needs to be a function of X, and fortunately for us, that's the way it was given to us. So in this case, it's going to be P times X, where P is negative 1/30 times X plus 300. We'll multiply that by our quantity, which is simply X, and we have our revenue function. Now, I'm going to multiply this out because the next step is going to be to find the derivative of this, to find the marginal revenue. And if this is multiplied out, it's a little quicker. I could do a product rule up here, but it's a little quicker to have it in this standard polynomial form. So next up is the derivative of the revenue, to find the marginal revenue. The derivative of negative 1/30 x squared, we'll pull that constant out of the way. The derivative of x squared is 2x, so I'll have 2 times negative 1/30, which would be a negative 1/15 x, plus the derivative of 300x is simply 300. Now specifically, we're looking for the marginal revenue at 3,000. So the idea is we're producing 300 sets, or 3,000 sets, excuse me, and we're looking for the marginal revenue. That value then comes from placing 3,000 into the derivative of the revenue function. And if I calculate this, let's see, 15 goes into 30 twice, so this is negative 200 plus 300, which would be 100. Now the units on a derivative is always the units on the function divided by the units on the variable. So this would be dollars per TV set. Right? And the interpretation of this is that at the production level 3,000, the revenue is increasing by $100 per TV set. What this means is that if I increased production to 3,001, we would expect to see the total revenue go up by $100.